How to plot a ground reaction force, Part 2, Plotting in Python, a series of biomech talk. Okay, hello everybody. This is going to be a Part 2 video of how to make a ground reaction force time curve. And so in the first video, I went over the data set and I talked through how to find the data set and check that the data was going to work for what we wanted to do. And then in this video, I'm going to be showing you how to actually make the plot in Python. So I'm using an IDE which is called Pycharm, and this basically just kind of like sets up a user interface where I can use Python within what's happening on the screen. So over here on the left hand side you can see the folders and the different files that I have within the project. I created a new project called biomech which I'm using here, and it has its own environment which is also called biomech, and I'm using Python version 3.1. And with that biomech environment, I'm going to be installing a couple of packages that we're using for this example, and then I will go through that information. And so on the right hand side, when we have data imported, we can view it over here, and when we have the ground reaction force plots, they're also going to show up on the right. In our console down below, this is where we're going to run our scripts. So first thing I'm going to do is start by making a new file. I'm going to right click, new Python file, and I'm going to name this ground reaction force plot part 2. And so this just got added to my biomech folder which I'm in, and then here this is where I'm going to start coding the script. So I always like to say what I'm trying to do up at the top, so creating a ground reaction force time curve in Python is going to be the title of what we're doing today. And those comments are going to be really important, so you want to make sure that you're doing that throughout the process. So the first thing we always need to do is import packages. So I'm going to start with the packages that we need to import. So the first package that we're going to be using is called pandas. So we're going to import pandas as PD. And I already installed the packages previously, but if you haven't installed packages on your environment, you can go to project and then Python interpreter, and then you're going to go to this plus symbol, and then if you need to search for the package, you can type it in there. And once it loads for a second, that pops up and you can install that package. I've already done this beforehand just to save us a little bit of time, but if you haven't installed the packages, that's where you can go. Okay, so next, so we're importing our packages, and we're going to be using 3 packages today. So I'm using pandas, matplotlib, and then another package which is called OS. So I'm going to import those. And then the as PLT, that's basically just like shortening the name of the package, so that makes it a bit easier for us to call functions from within those packages. So I have those 3 packages. Pandas is going to help us with dataframe, so when we import our text file, that information will go into a table. And then OS is going to help us with some of the path information that we need for the files. So again, we're doing our comments. So now that I've got my packages, I'm ready to import my data. So I'm going to start by getting the path to the folder where I want to save out the files, and also where I've stored the file with our force data in it. So then I also need the name of the file, which is going to be this. And you can download whatever file you want from the dataset, but I'm just going to use that as an example if you want to follow along with me. And then the little r in front of the string basically just helps with the system recognizing that this is going to be a path, so it helps with the orientation of the slashes. Okay, next. So now that we have that, we're ready to import data from our txt file. So I'm going to go dataframe force. I'm using this notation just so I know that the data that I'm looking at is going to be in the form of a data frame. A data frame is basically a table. So I'm going to go read CSV, and then I'm typing ospath.join, and then I'm going to use the path that I just specified and the file, the text file that I'm using. And then we want to write separator equals -t. And the reason that I'm doing the -t is because we're using a text file instead of an actual CSV file. So we just have to specify what the separator is going to be from that file. So just to show you what this looks like, I'm going to copy the os.path.join part into my console. And then, we need to make sure that we run this first. And to run that, I am highlighting the text and going Alt-Shift-E, which just imported those packages. You see that I have no errors, so I was able to import those successfully. Then I'm going to run this next part, I'm showing you what's happening with the os.path.join. If I copy that into my console there, that is also not defined, so I need to run these first. Okay, so now you can see I have path over here, I have my file text, so now I'm ready to show you what this function does. So copying that into my console, you can see that that's where the file is located on my computer and where I'm going to call in that data from. So if I now run this line, you can see that we ended up with dataframe force, which looks the same as the information that we pulled into Excel to check it last time. So you see we've got our time column, force in the X, Y, and Z directions, our center of pressure data, and I'm not sure what the TY means, but we will ignore that for now. Okay, so that's how we got set up with importing our data. And now next we want to get into actually plotting the data. So just for starters, remember that this data has increments of 30 seconds of time. So here I'm just going to be pulling in the full ground reaction force time curve, and we're just going to see what the whole thing looks like. So we'll start by, excuse my spelling as we go, initializing the plot. So we're going to do that by doing plt.figure with open parentheses. And PLT, again, is just calling that matplotlib package, and we're using a particular function from that package. Then next, I want to plot the data on my plot that I just initialized. So I'm going to be doing plt.plot, and then I need to specify what I want on the x-axis. So in this situation, I'm going to be plotting time, because that's what we have in our data frame over here. Then on the y-axis, I want to plot the fx data, and then just to start off, I want to specify the color so I know what line is what. I'm going to give that the color of orange and a label of fx. Okay, so I've got that there. Just to give you a sense of what that's going to look like, I'll run those two lines. And if I go into my plot section, this is not showing up, but if I go plt.show, now we can see our plot there. So again, that looks like reminiscent of the plot that I made at first and was very confused by, but we will keep going. So now I want to get the other components of the reaction force. So we have fx, fy, fz. So I want to get all of those components going. So I'm going to copy those lines, go fx, fy, fz. I'm going to make the fy data blue, and I'm going to make the fz data red, and this is labeled with fx, fy, fz to match what we plotted there. So we're going to run these lines again just so you can see what happens. Okay, and so now it looks like we've got our three components of the graph there. So I'm going to add a little bit more information to our plot. So I'm going to add axis labels, and we're going to do this by plt.xlabel time in seconds. Or actually, this is going to be time as samples for now. We'll come back to that later. And then on my y label, we've got the ground reaction force in newtons. Then I'm going to add a title to my plot, which is going to be just ground reaction force time curve. And we can run that again so you can see how that updates and gives us labels on our plot, which is good. Okay, so last time we talked about how this is a 30-second chunk of the data, just to give us a sense of what an individual ground reaction force time curve looks like for a foot contact. We're going to zoom in on a specific piece of the data. So if I go into this data frame and I'm looking at the FY, because this is going to be my vertical data, you can see that we're hovering around 0 for a little bit, hovering around 0, and then here it's going to start to increase above 43, and my number is going up and up and up, up and up and up, and then my number is going to start to drop back down, and then here we're going to hit 0. So that's going to be the first contact that's showing up in our data set. And if I look at the index, it ends at this number 107, and then if I go back up to the beginning to find where that started, it starts at this index of 43. So I'm going to limit my data and just plot a single force time curve. So I'm reducing the data down to the first force time curve. Okay, and so to do this, really easy, I'm basically just keeping it between those indexes, which I said were 42 to 106. So that I'm gonna go df force 1. So basically I'm creating a new data frame by using the old data frame. I'm gonna go iloc, which is going to keep track of our indexes, and I want to keep 42 to 107, so that's specifying the rows. Then I'm going to add a comma and then keep this double colon, semicolon, whatever it is, colon, and not specify any numbers there because I want to keep all of my columns. So when I run this line and I click on this here, you can see that we have all the same rows that we had before, but now my data frame is limited. So I only have the information going from 42 down to 107. So that's going to help me plot a single force time curve. And so the other thing that I want to pay attention to is making sure I'm keeping my data above a specific force threshold. So you can see that this data starts around 43. But then when we go to the bottom over here, the data drops down to 30 and 35 newtons. So just I'm going to use a force threshold of 40 in the vertical direction. This is pretty common in the literature, just making sure that we are defining contact at a certain interval above a certain force threshold. So I'm going to say my threshold force is equal to 40. Again, this is in newtons for the vertical component of our ground reaction force. And then I'm going to filter if Fy, which again is our vertical, is above threshold force. So in order to do that, I am going to reset what I'm saying my data frame is equal to. And I'm going data frame force 1, and I'm taking a subset of this, and I want data frame force 1 where Fy, this is specifying the column, is greater than threshold force. And I can auto-complete that once I have that in there, which is really helpful. Next, now, well, let's go ahead and run that part so you can see what happened there. So back at the beginning, again, this is just stuck at that 43, but then, oh, threshold force is not defined. Sorry about that. Okay, I need to run this part first. that makes sense. Okay, and we're gonna look at our data frame. We can get rid of the old ones. Okay, so you can see that this starts at 43, and then if I scroll down, this also cut off those 30 and 35 that were above that 40 threshold. So that way I know what I'm defining as my contact, so I know how long the person is going to be on the ground. So next you'll see that this time data right here is actually in samples. It's not in seconds. So in order to help us understand what the contact time is, we need to adjust this time from hertz into seconds. So with that, we're going to reset our time series. And first I'm going to start off, I need to know what the sampling rate of the force data is. And I looked this up in the paper, so it's going to be 300 hertz. So sampling rate of force data in hertz. Okay. And then after that, I'm going to reset the time series so that the start of my contact is going to be set to 0, and then the end will be something else, so then I can figure out what the contact time is. So I'm going data frame force 1, and I'm going to make a new column, which I'm calling time reset. And when you're manipulating data, I highly recommend making a new column so that you don't mess up previous things that were happening with the data set. So I'm going data frame force 1, I've got time, and I'm going to subtract off what the sample is in the first index. So I'm going here, 1, and then I'm subtracting time, and I'm pulling, we need iLoc 0, and that iLoc 0 is basically going to pull this index of 44, or this time of 44, so that I can reset this whole thing. And then I also need to divide by the sampling rate of the force, and then that's going to put our time reset. Let's go ahead and specify that this is in seconds. So we will run that line. And then when I click on my new data frame, you can see that I have a time reset. So this was set to 0, and then if I scroll down here, I can see that the contact time with that 40 Newton force threshold that I set is going to be 0.203 seconds for this foot contact that I'm looking at. So that's good. We've reset our time, and now we're ready to replot the single ground reaction force curve. Okay, so again, we're initializing our plot like we did before, and we're going to plot the data very much in the same way that we did before. So I'm going to copy this from up above and then just make some adjustments. So I'm going to be taking from data frame force 1 instead of our raw data, and then with the time I want to be using my time reset seconds, and I can copy that here and double click and it'll highlight and repaste that in there for me. And I want to be keeping the same information. The only thing I'm going to change, just to add a little bit more detail, is the fx, fy, fz. So I know that my fy is in the vertical direction, so I'm going to label that as vert. The fx is going to be the anterior posterior component, so the braking and propulsion of that data, and then we also have the medial lateral. Okay, so that's going to plot our data, and then again we're going to add labels to our plot. So we've got PLT X label is going to be time in seconds. PLT Y label is going to be ground reaction force in newtons, so that stays the same. Then my title is going to be ground reaction force time curve, and I'll call this first step because I'm just looking at one ground reaction force time curve. And then let's go ahead and start with that. I need to do plt.show, otherwise my figure is not going to show up in our little plot area. So this is looking pretty good, but there's a couple things that I want to note and add. For whatever reason, matplotlib adds this little like white space around the data, which can be a bit misleading and kind of confusing. So I like to get rid of that. So in order to remove the white space, we're going to do plt margins and say x equals 0. So let's run that again. All right, that's nice. So now we can see that got rid of our extra space on the end, which is really helpful. And then another thing that I want to do is add in my legend labels. So I have these labels for what we're calling each line, but you can see they're not actually showing up on the plot. So in order to specify that, I want to add my legend. We're going to do plt.legend with open parentheses. And I can plot that again. Awesome. So now you can see the blue curve is my vertical ground reaction force. The orange is going to be the anterior posterior, so you can see how we have braking and then going into propulsion. And then the medial lateral force is our red line there. And you can also see that this data is not filtered, so it's very bumpy and jagged because it was collected on a treadmill. So that's something to keep in mind. If you were going to use this data, you would probably want to filter it using the recommendations of the filtering that they did in the paper. And we can talk about that in a future video also. Okay, so now we have our plot. I'm pretty happy with that. And you could repeat that process for whatever curve that you wanted to plot within the overall force data, any of those 30 seconds of foot contacts that show up there. So now that I have this, I am going to want to save out my plot. And to save out my plot, I'm going to go plt.savefig. And again, I'm using my os.path.join function. I'm going to use path. And then I'm specifying the name of my file, which is going to be ground reaction force time curve.png. PNG is an image file that I'm going to save it as. DPI is specifying the dots per inch, so basically the quality of the image when you zoom in. And then if I want to again keep this tight layout, I'm going to specify bbox inches equals tight. Okay. And then the other thing that you got to keep in mind is that show needs to be after save figure. So for whatever reason, if show comes before save figure, it will not actually save out the plot that you made. So make sure you run that per second. So I just saved out my figure. So if I go to my folder here where I had all my data, you can see that we had this file, which was created at 2:04 when I'm doing this. And I can open that up and it saved my file into the folder. So that is how you create a ground reaction force time curve using a text file that I got from the internet. So hopefully this was helpful, and let me know what you think. How to plot a ground reaction force, part 2, plotting in Python, a series of biomech talk.